Hello, this is Mr. Jarrett, and in this video tutorial we are going to be 3D modeling the remainder of these miniature train parts and going through the assembly in SOLIDWORKS. So depending on your class year, this may change from year to year, but in most cases you probably have already drawn a lot of these parts for the train. So the assignment number might have changed just because I change the class all the time. So what I want you to do is kind of just look at the pictures and think back of what you've already drawn and kind of just check it off. So for the year that I'm actually making this, the students would have already made this linkage arm, the axle peg, you would have made the smokestack, the wheel, the train body, and the cow catcher. That's in most years. So depending on when you're actually taking the class, you may have more done than that. So the extra files, and the reason I don't necessarily draw these in classes because they're so easy, are just these remaining ones. The linkage peg, the hitch magnet, and the hitch peg. So we're going to start out by drawing these. And as you can see, they're all in inches. Majority of them are oak. This one's oak. Okay, so I guess this is alloy steel and cast carbon steel. Okay, so I'm going to pull this to my other screen, and I'm just going to simply start out by making new parts. We're going to go right through each one. We're going to draw the linkage peg first. Make sure you're in IPS, and I'm going to be sketching right on the front plane. So it doesn't necessarily matter where you put the origin, so I'm just going to put the origin down at the bottom. I'm going to go straight up, and then that says spherical radius. So if you have the line tool, you can move your mouse over this dot so it curves. If yours does not do that, then you can just get the curve tool. Okay, so I'm just going to come straight in and down like this. So a spherical radius means when this is an actual three-dimensional shape, you don't have a dimple here. So meaning the center point needs to be on this center line. Okay, so then we can go ahead and actually dimension this. So it says that this has a diameter down here of 0.0625, but we're only drawing half of this currently, so you have to divide that by 2. Okay, and you can set this to 4 or 5 decimal places if you'd like. This is actually 5 decimal places. Doesn't matter to me if you do that, though. Okay, then this is 0.25. And we do not have to divide that by 2 because we're talking height here. This is 0.325. And it says that this has a radius of 0.1562. Kind of an odd measurement. Make sure that the center point is coincident with this center line, so it's right on that center line. And you can go to the Features tab and hit Revolve Boss Base, and we want this center line as the axis of revolution. Okay, we can change our material to oak. You probably have to go into Edit Material and down to Wood. I have mine set as a preset, but I probably did not do that with you in the past. So Edit Material, go down to Woods and Oak. Apply and close. And you can evaluate it and check it, but I know this is correct. So I'm just going to save this. You can go File, Save As, and you can save it as the linkage peg. Then you can start a new part file. And you notice I didn't save mine because I already have these done. But you're going to make a new part file, and this time we are going to be sketching right on the top plane. Again, we are in IPS. Doesn't matter if you go on the top plane or front plane, but we're going to be drawing with the circle tool, 2 circles. Both centers are right on the origin, and then you can go ahead and start to dimension this. So the outside is a diameter of 0.45. The inside is a diameter of 0.25. And we're going to extrude this a total of 0.25. We can change our material. That's alloy steel. So notice that's not one of these presets. So we can hit Edit Material. And in the steel folder, we just need to scroll down until we find alloy steel. Hit Apply and close. And now you can save this as well. And this is the hitch magnet. Then we can make another part. And this time we are going to do the hitch peg. And this one's very similar to the linkage peg. It's just a little bit different in shape and size. So again, I'm just going to draw this on the front plane. Origin right here in the middle. This is still in inches. You can use or wiggle your mouse back over that dot with the line tool, and it should give you a curve. If it doesn't, then you can move your mouse over that again. You see it kind of changes through the different curve tools. Straight over, down, and back. Okay. Then you can go ahead and you can start to dimension a lot of this. So 0.5 is the underneath height. The overall height is 0.65. And mine kind of got messed up here. So if you hit escape and you move your dots around to keep that general shape, that's what you're looking for. So this line down here at the bottom, it says it has a diameter of 0.25, but we're only drawing half, so we're going to divide that by 2. So that's going to be 0.125, as you can see. Then once again, we have a spherical radius up here, and that is 0.208. Okay, 0.208. Since that's radius, we don't have to divide that by 2. 0.208. Make sure that your center point for that curve is right here, coincident to this center line. Then we'll go to the Features tab and Revolve Boss Base. And once again, we're going to be selecting that center line there. Hit the green check. And now we can change our materials. So this is cast carbon steel. Cast carbon steel. So we're going to hit Edit Material, because that is not one of the defaults. Scroll down, you see cast carbon steel right there in the steel folder. Apply and close. And now you can save this as the hitch peg. So now we have those 3 drawn. And from here, we are going to start assembling our train. So we can start by making a new assembly. And we're going to be doing this all in IPS. So when you open up a new assembly, it's going to ask you what you want to insert. Sometimes this box does not pop up. If that's the case, you have to hit Browse down here in the bottom left. And you can see I have a whole bunch of files in here. And you'll be seeing that this is going to take us a long time. There's one with constraints, one without constraints. There's a lot of different stuff that we have to do here. So we're going to do this bit by bit, easy things first, and then we'll kind of get into the more challenging stuff. So when I say easy stuff first, I mean we are going to be putting in the train body. So I believe the train body is going to be assignment 19 in most years. Okay, if yours is not really showing your pictures, or if your years are, my years are different as far as the assignment numbers, you can change your thing over here, your more options, and you can change this to like icons. And most times it'll give you the pictures. Okay, so assignment 19 for me, the year that I made this video, is the train body. So I'm going to be bringing that in. I'm going to hold in Control, and I'll do the cow catcher because that's pretty easy. I'll do the hitch magnet. I'll do the hitch peg and the smokestack for right now. Okay, and I'll hit Open. So it's going to ask you to place them in, so you can just click to place. And I'm going to kind of just put them in the areas that they need to be. So behind the train and in front of the train. And the smokestack goes up on top. Okay, so let's start with this first. You can see there's 3 holes there. And back here there's 3 holes, or 3 pegs. So obviously those go right in those. But before we even do that, we want to make sure that our the train body is actually fixed in place. So you can see if I try to move it, since this went in first, and it goes by alphabet, so alphabetical, this one was assignment 19. If your train body is able to move, and say your smokestack is stuck in place for some reason because you had these labeled differently, what you need to do would be right click on this, and you would have to hit float, or fix, sorry, it would say fix right here. And your smokestack you would want to float. But for me, you saw I have the float because this is locked in place, it's fixed. So we want the train body to not move. We want everything else to be underdefined and be able to move. Okay, So to start out, we're going to get our mate tool, and you could do this a bunch of different ways. I think a very easy way is kind of just putting this top peg in first. So if we just click right in here on the inside of that cylindrical hole, rotate around and click on the cylinder itself, cylindrical peg. Notice it makes them concentric, so we can hit the green check. And now this thing is kind of stuck in there. It can still rotate and wiggle. So if we do the same thing for this peg, click on that peg and this peg right here. Now it can't rotate anymore. The only thing it can do is slide in or out. So that's pretty simple. Click on the front of the train, back here of the cow catcher, green check, and now it is stuck in place. Okay, so that's number one. Let's go back here to this. So the inside of the hitch magnet and the cylindrical part of the hitch peg, and we're actually going to check the box here for lock rotation so it doesn't rotate on us. Green check, and we'll click on this piece and underneath, so those two go ahead and touch. And if you're wondering what this actually is, in the old toy trains that were like this was kind of just like a bolt that was glued in. I don't think it had threads, it just got glued in. And this is actually a magnet. So since this is a piece of metal that is magnetic, this round piece would be on the front of the next body of the train. So this is the very front car of the train. Obviously you have the, your cow catcher on it. The next train body piece would actually have this same connection piece, but on the front. So as it rotated around, those two curved surfaces were just kind of magnetic to one another, magnetized to one another, and just rotated on top of one another. So now let's do this. Let's click on that cylindrical part and this hole. Okay, so it lines those two up. Again, we can lock the rotation so it doesn't rotate. Green check. Then the back of the train, and you have to zoom in here and click on the back side of the magnet. Okay. So now that is stuck. That thing can't move. Same thing for the smokestack. Let's click the cylindrical body piece right there and cylindrical part of the hole, and we'll lock that rotation. Green check. And right now it kind of went inside the body. That's kind of hard to do what we need. So let's move this up. And you can see I have a flat bottom there. If you don't have a flat bottom, because maybe you did yours differently, you can just use this ring. I'm going to use my flat bottom and the flat bottom of this. Okay, and green check. So that thing should not rotate, should not move anywhere. It's stuck. So if you're ever wondering why did we have to do 3 mates for this and only 2 for those, because we checked that box of lock rotation, that would actually be that 3rd mate. So that pretty much finishes up all of the easy stuff to do. And I say easy stuff because moving forward, you see we actually put threads in here. And we actually put left-hand threads and right-hand threads, depending on what side this was on. Now, if we were in person, I would probably show you the in-depth way of actually threading and doing the correct mate to thread those bolts in there. Since this is going to be a virtual lesson here that maybe you're watching from home, or you are doing as a catch-up because you got behind on your work, I'm not going to take you through that tedious, long process because you actually have to do that for every single one, and it does take a long time. I actually paused the video during this recording and tried to see how long it would take me to talk through doing one of them, and it was way too long to actually have to do that through all 4. So we are going to be putting those bolts in, but we're kind of just going to ignore the fact that these have threads. So we're going to insert components, and now we are going to be bringing in the wheel and one of your actual bolts. So I don't care if you bring in your right hand thread or your left hand thread. It really doesn't matter because we're going to ignore the fact that it even has threads on it. We're going to hit open and place those in. And on our wheel, it actually has this little flat spot right here. Okay, you can kind of see it curves up and then it flattens off. So as you can see, it's flat right there. So we're going to use that flat spot to our advantage, and that's going to go underneath here. And obviously this is going to go right through the hole. Now, since this does have the threads on it, it is kind of hard to click on the actual cylindrical part of this. You can do this ring out here because it's still going to be the same thing. It'll just line up the centers, but I'm going to show you something different. Up here where you see you have all these different small little options, this display style, and then there's the eyeball. Okay, the display style is something you've probably used before, or maybe this little view cube to rotate around. This eyeball is where you can see a whole bunch of different settings that you can currently turn on or off, like your relations if there's a lot of relations. Well, there's also temporary axes. Okay, so I'm going to turn on this temporary axis that's underneath that eyeball. And for an odd shape like this that has those threads, here it actually puts an axis right through the middle of anything that has a circle, okay, or anything that has a hole. So it's going to be a lot easier to line these up. We're going to get the mate tool, and I'm just going to click on those axes. And you notice it kind of rotates there and lines those up. Now it also made my wheel go the wrong way. If it does that for you, you want to change your mate alignment. Okay, and that's just down here. Hit the green check. I'm going to zoom in. I'm going to click on this flat part here, rotate around, and I'll click underneath this bolt head. And you can see now the bolt head is going to be resting on there. And I'll hit the green check. Then I'm going to select this axis. I'm going to zoom into one of these holes, select that axis. Again, if it's facing the wrong way, you can rotate that around. Okay, so this really should be over here more. So I'll just hit the green check and then I'll move it. Okay, and then I'll click on the flat wall, rotate around, and click on this flat wall. Now again, I am not actually doing the correct mates here. I'm doing this like there are no threads. If you want to learn how to actually assemble this by using your threads, I placed this video, I hyperlink this video right here on our document. It says if you want to learn how to actually assemble the threads the correct way. I put a link here, and this is how I learned it. This is somebody else that I found on YouTube, and they actually show you how to do it. So basically, underneath your mate tool, these are all called your standard mates. You then have advanced mates, as you can see. You also have mechanical mates, and that's what that would be in. There's cams, there's gears, there's screws. This is a much higher level. This would be something like a Tech Draw 3 or a college level class would really get into all this. This is motion constraints and such. So I'm just going to be assembling this like there are no threads. So I click this sidewall of the body and the back half of the wheel. Okay, and that's going to be a standard mate and coincident and green check. So as you can see, it's kind of sucked on there. And this is just going to rotate. So in real life, if you actually wanted to make this correct, your bolt would actually have to have what's called a shoulder. A shoulder on a bolt is like a smooth part before the threads so that this could rotate correctly on there. Okay, so that's basically the process of putting those on. Now I know a lot of you would say, well, can we just mirror this back and mirror this over? No, you can't, because if it's a mirror, every time you rotate this, it's going to be the exact same rotation for those other tires. So unfortunately, you do have to bring this in and you do have to mate it multiple times. You could do insert component, but me teaching you here is all about learning something new. So another way of inserting a component is actually holding in control. Okay, but before we actually do that, what we can do is actually make what's called a sub-assembly. So if I select the wheel, hold in shift and select the axle, okay, I can right click on these and I can say form new sub-assembly because it's going to save us a couple mates. So now these two are one sub-assembly, as you can see. So like I said, if we hold in control and not drag from in here of one of these parts, but drag the word from where it says assembly, you drag that and drag it in and let go, you see it copy those two. And these two are already stuck together. So that just saved me about 12 clicks. So you can do that again for this side, do it again for back here, and that's going to save you a significant amount of time. As long as you bring in the correct amount. You can see I brought in 5 wheels here. So now let's go ahead and do that once again. So I think it's easy if you just zoom in, you click on this axis, click on this axis, green check, that wall to the wall it's going to touch, green check. So that just saved me a lot of time, as you can kind of see. Now when you're doing the wheels on the opposite side, make sure you do have to flip the mate alignment so the wheel's facing the opposite direction. So if you didn't just see what I did here, I had to do a mate alignment so it flipped around. Okay, wall to wall, green check. You can see these temporary axes actually come in handy. It's a lot easier to click on. Mate alignment, so that rotates around, green check. So just to kind of brag about how good that forming a new subassembly was, you think about this, I just had to do roughly 12 clicks just to assemble one of these wheels. So there's 12 times 12, or 12 plus 12 plus 12, and that's not to mention the extra 12 plus 12 plus 12 you would have had to do to put that axis in. So that's a lot of clicks. So I just saved you a bunch of time. So now all the wheels are in. You can still use these axes if you'd like. You can turn them off if you don't want them on there. Since we do have some other circular things, I'm just going to keep mine on for a little bit. But now we're going to insert the other components. And now we're going to do the linkage peg and the linkage arm, which is probably one of the very first assignments you drew in this class. Okay. And this basically just goes on there and connects to the other one so that they move together. So again, we are just going to use that axis, zoom in on that axis, okay, green check, and then you're going to do this flat part here or the outside piece, doesn't really matter, just make sure you know what you're actually clicking on. So I clicked on that outside piece and I'm going to do the outside here. Okay, so you see they're flush. So it really doesn't matter which one you do, just make sure you're clicking on the corresponding side that actually touches it or is flat to it. Okay, so I'll do that same thing again, this axis to this one. And you notice it probably rotated and flipped all the way over there, green check. And since we already said the outside here needs to be flush, that automatically is going to be flush. Okay, so you can see now when I move this, they actually move together. Now we're going to be putting this little linkage peg in, and since this is so small, sometimes it rotates and goes inside your train body. So what I like to do first is actually go up to where it says move component and select the drop down, and I like to rotate this thing so that way it doesn't flip and rotate and fly away on us. And I just kind of rotate it in the direction it's going to be going. Now I'll hit mate. If you want to drag this somewhat closer, you can try. So you might want to go to a different view. Okay. So I don't want that point, I actually want this axis. And we're going to do that axis back here. Green check, click that flat piece, and underneath, and green check. Okay, so now that's on. So you don't really want to form a subassembly here with these. I mean, I guess you could, but you wouldn't really be able to see this side as well. So what I'm just going to do is just show you how control will actually work. You just hold in control and click on that part and drag, it copies it off. It's the same thing as inserting the component. So I'll just go through that same process again. So axis to axis. And then flat side to the flat side. Okay. Now that you have all three of these, if you want to form a subassembly, you can. So you can hold in shift and select those. And you can say new subassembly. But you most certainly don't have to. You could just insert the components again and put them on the other side. But I'm just going to copy this and bring this over because those should all be at least connected together. So let's see if we can do this part now. Easy enough. So you might have to move your mouse over that axis a little bit. I noticed out here it wasn't really giving it to me, so if you move your mouse in, it did give it to me a little bit easier. So same thing here, you might have to move around on that axis so it allows you to select it. And you do have to do the mate alignment because we're on the opposite side. So change your mate alignment for flip-flops. You might want to drag this out a little bit. And before I actually put this flat on here, I am going to do the other axis on the opposite wheel just because I think it's a little bit easier to click on now before it gets covered up. So basically those are aligned way out here. It's just not touching. So that kind of looks funny, but it's actually doing the correct thing that it needs to be doing. Okay, so then this time we're going to use this flat piece and the underneath side, and that should be on there correctly. We only need to do it to one of them. So if I hit the X and I go back to an isometric, I'm going to turn off my axes, my temporary axes. That's the eyeball, and unclick that one. As you can see right now, this thing looks like it's done. Most people say, hey, this is pretty cool. Well, it is, but if you can see what's going on right now, a train would not work like this. Okay, a train would not be able to go forward. So that is a problem. And the other thing is, the other side does not move while we move these. So we're going to save this right here. So I would go File, Save As, and we're going to actually fix this issue. Okay, so once you've saved it, what I'd like you to do is go to a side profile, like a side view of this, rotate this wheel around until you actually have this linkage arm up at the top. There we go. Doesn't have to be perfect, just somewhat up at the top. Go to the other side, and we want this to be opposite. So this is going to be at the bottom this time. If you think about how a train works, they both aren't going to be at the top together. One's going to be at the top, one's going to be at the bottom like this. Okay. And now from here is going to be a little bit of a new thing for you. What we're actually going to be doing is mating the planes that are already existing inside of our parts. So when you draw a part file, you know you have your front, top, and right plane. Well, those actually carry over into your assembly. So you see the assembly file itself has its front, top, and right plane, but so do all of the individual parts. Okay, so we can use those planes to our advantage and actually assemble with those. So first off, I'm going to find this wheel. Okay, so you can just select one of the wheels. And when you do that, it kind of expands things. And you see it's down here. I'm going to expand that a little bit so I know what's what. And then the wheel on the same side, so this one, I'm going to do the same thing for. See how it expands it? And I'll expand that. Now the reason I did that is because it's a lot easier to do this and kind of look through this when it's a large menu versus that small menu in the mate window. And I'm going to try something that I haven't done before, but let's try this right now and see if it actually works. With these all expanded like this, we're going to actually try to select the front plane, okay, of that wheel, hold in the shift key, scroll down, and select the front plane of the other wheel on the same side. So I selected those two wheels. Now actually if you hold in shift, you see it selects everything in between. So let's try to do this again, but hold in control this time. All right, so that worked. So I held in control and I selected both of these planes. And now I'll get the mate tool. And by doing that, it actually already had them selected here, which is nice. Now we do not want them to be coincident. We actually want these to be parallel. So we're going to change this to parallel. Okay, if they were coincident, this would never rotate because right when this starts to go up, this obviously can't go anywhere now. So parallel and green check. So what that actually solved was that problem of the linkage peg being down here and up here. So you can see now this thing is always going to be perfect. It's never going to get that glitch where it's up there and down at the bottom of the other one. So I'm still going to keep this towards the bottom. I'll rotate around to the other side. And I'm going to compress all of this stuff so I don't get confused. Okay, or mix it up with the wrong set of wheel. And now I'm going to do that on this side. So this one is that wheel. I'll select that one, and it's that wheel. So since we have 4 sub-assemblies, and these are inside the sub-assemblies, this is a lot easier to do it this way. So select the front plane, hold in shift, find the other one, or hold in control, sorry. Holding control, find the other wheel and front plane there. And now we'll go to the mate tool. And again, we need to change this to parallel. Green check. Get off of the mate tool. And the last thing that we need to do here, we're going to compress all this stuff, is we are going to actually make this front wheel and this front wheel, their front planes parallel. So we'll select this wheel so it expands, select the other front wheel so that expands. Select the front plane, hold in control, select the front plane of the other wheel, and let's go up to mate and make those parallel as well. Green check. Now, if we get off of mate tool, hit Control 7 and we rotate this, it should work correctly. So maybe I got to do it with a linkage arm. Yeah, as you can see, maybe go to a better view here, something like this. As you can see, when I rotate this, now they rotate opposite of one another, and I never have that error, and this is actually how a train would work. So that's pretty cool. If you want to take this any further, you notice on here on the very bottom of this, I actually drew the straight track, and I even put in a picture of the curved track. For the grooves that get cut in this, they're the same thing as this, it's just this one's curved. Okay, so if you'd like to do that, you can. I've actually seen people go ahead and assemble the entire thing and actually put this on the track So I do not have mine up to date now that I have threads on these, but you can see in this little preview here what it would look like. You can do a whole bunch of curved tracks and straight tracks combined to one another, just like the actual toy would do. And there are videos online, because I'm not the only person that draws this train. There are videos online that will actually show you how you can assemble this onto that track and actually have motion constraints so it will actually go around and around and around. But of course, that is enrichment. So from here, I would just save it and move on to the next one.